Good day, everyone. I am Micaela Escalacia, taking Bachelor of Science in Entrepreneurship, and I am going to tackle about or discuss about the measures of relative position or quantiles of ungrouped data, since this is assigned to me by our GE4 professor. Before we're going to discuss the measures of relative position or quantiles of ungrouped data, let us know first what is measures of relative position. It is a number that tells where the score stands relative to the others in a set of data. It is a measure whether a value is about the average or whether it is unusually high or low. It is used for quantitative data that falls on some numerical scales. It means it is a numerical data. It can be applied to ordinal values. A measure of relative position determines the position of a single value in relation to other values in a sample or a population dataset. Unlike the mean and the standard deviation, it is based on quantiles and not sensitive to the influence of a few extreme observation. It gives us a way to see where a certain data point or value falls in a sample or distribution. We will going to know also what is ungrouped data. What is ungrouped data? It is a data you first gather from an experiment or study. The data is raw. It's not sorted into categories, classified, or otherwise grouped. It is basically a list of numbers. From the word itself, ungroup, it means it is not yet into place. It is not yet sorted. So it means the data is not order. It is not yet in order. So they are I've prepared three common measures that is seen in the measures of relative position or quantiles of ungrouped data. First is the quartiles of ungrouped data. The quartiles are those score points which divided a distribution into four equal parts. So to know our second quartile, our 50% will be the median, or it means median means the middle part of the data. Second percent of the data will fall into the first quartile. And just like what I've said earlier, that the 50% will be going to go under the second quartile. The 75% belongs to the third quartile. So in order to get the interquartile range, you will going to get the difference between the third quartile and the first quartile. I've prepared some examples for you to know more or understand more the quartiles of ungrouped data. The first example will be the owner of the milk tea shop recorded the number of customers who came into his shop each hour in a day. The results were 14, 10, 12, 9, 17, 5, 8, 9, 14, 10, and 11. Find the lower quartile and the upper quartile of the data. First, you will going to arrange the scores in ascending order. Our n will be 11 because There were 11 results. That is why our n will be 11. 5, 8, 9, 9, 10, 10, 11, 12, 14, 14, 17. That will be the scores in ascending order. Ascending order means from lowest to highest. 10 will be our middle value since it is the middle of our scores. 9 will be our lower quartile. In order to get the lower quartile, you must get the middle value between the second quartile and the first score of the data. So our first score is 5 and our middle value or our second quartile is 10. So the middle part of them will be 9. So that is our lower quartile or our first quartile. And and like and in order to get the upper quartile, you must also get the middle value between the second quartile and the last score of the data. So our middle value or the second quartile will be 10 and our last score of data is 17. So the middle part between 10 and 17 is 14. So 14 will be our upper quartile. So to compute the interquartile range, we will get the difference between the third quartile and the first quartile. So third quartile or the upper quartile is 14 and our lower quartile or our first quartile will be 9. So 14 minus 9 is 5. So our interquartile range will be 5. So to sum it up, our lower quartile will be 9 and our upper quartile of the data will be 14 and the interquartile range is 5. So the second example, consider the set of scores in a quiz in Science 12 of section Benevolence. 11, 13, 14, 15, 15, 16, 19, 19, 20. Find the first quartile, second quartile, and third quartile. So arrange the scores in ascending order. So our n will be 9 because there are 9 set of scores. So 11, 13, 14, 15, 15, 16, 19, 19, and 20. So that will be the scores in ascending order. So 15 will be our middle value, middle or the median, because it is the middle part of the data. So it will fall under our second quartile. Our second quartile will be 15. Since there are no middle value between the first score of the data and our second quartile, and also we cannot get our third quartile because there is no middle part between our second quartile and the last score, we will going to add the two middle part. So in order to get the first quartile, we're going to add the 13 and 14 and divide it by 2. We will divide it into 2 because there are two variables. So 13 plus 14 will be 27. 27 divided by 2. So 13.5. So our first quartile or lower quartile will be 13.5. And to get our third value or upper quartile, we're going to add the middle part between 15 and 20 since the middle part of it is 19 and 19. We're going to add 19 and 19 divided by 2. 2 since there are two variables. So 19 plus 19 will be 38 divided by 2. So our third quartile will be 19. In order to compute the interquartile range, we're going to get the difference between our third quartile and our first quartile. So 19 minus 13.5 will be 5.5. To sum it up, our first quartile will be 13.5, our second quartile will be 15, our third quartile will be 19, and our interquartile range will be 5.5. The second common measures will be the deciles of ungrouped data. So deciles is the score points which divide a contribution into 10 equal parts. Our quartile range will be just belong into will just belong in to 4 equal parts, and our deciles will belong into 10 equal parts. So always remember that our quartiles is into 4 equal parts, and our decimal parts will be into 10 equal parts. So there are a formula dk equals kn divided by 10. So the k will represent what decile we will going to get. So for example, the decile of the first decile, so we will going to solve the d1 equals 1n. N, just like what I've said earlier, that n is what how many data or scores is presented. So that will represent the n, and divided by 10 since deciles is into 10 equal parts. So there are some rules in order to get the location for decile. The first one is if the quotient obtained is not a whole number, round to the next larger whole number. And our second rule is if the quotient is a whole number, use the value halfway between the kn over 10 th plus kn over 10 plus 1 raised to the power of th. So in order to understand it more, I've prepared some questions. So our third example of this whole topic, or the first example of deciles of ungrouped data. So find the third decile of the following set score of a random sample of 10 students: 35, 42, 40, 28, 15, 23, 33, 20, 18, and 28. So it is ungrouped data, right? So we will going to arrange the scores in ascending order. N will be 10 because there are 10 students participated in the random sample. So 15, 18, 20, 23, 28, 28, 33, 35, 40, and 42. So that will be our scores in ascending order. So our formula will be dk equals kn over 10. So since we are going to find the third decile, we will use the d3, or the third decile equals 3. Since we are going to find the third decile, so our k will be 3, and n is the how many scores presented, so they are 10. So 3 times 10 equals 10 because they are 10 equal parts. So 10 times 10, 3 times 10 equals 30 divided by 10. So our third decile will be 3. Since in the second rules that if the quotient is a whole number, use the value halfway between the kn over 10 th plus kn over 10 plus 1 raised to the power of 10. So since our answer is a whole number, we're going to find the halfway of the data, halfway value of the data. So the halfway between the third decile is the third decile and the fourth decile, and we're going to divide it by 2. So 20 plus 3, since our third decile is 20 and our fourth decile is 23. So 20 plus 23 equals 43 divided by 2, since there are two presented variables. So our third decile will be 21.5. So to sum it up, our third decile will be 21.5. Our third decile will be not 3 because it is already stated in the rules to get the location for decile that if the answer is quotient, if the quotient is in a whole number, we're going to use the value halfway in order to get the third decile. Our fourth example, or the second example of deciles of ungrouped data. Mr. Divigal is a Filipino teacher. He gives a 60-item test for remedial class. The scores of 15 students are 20, 35, 55, 28, 46, 32, 25, 56, 28, 37, 60, 47, 52, and 17. Find the value of seventh decile. So we're going to arrange the scores in ascending order. Since there are 15 students who participated, so our N will be 15. So that will be the scores in ascending order. So the formula, we will going to use the formula. So the the seventh decile equals 7 since we will going to find the seventh decile, so our K will be 7 and the N will be 15 since they are 15 students who participated in remedial class. Divided by 10 since decile is distributed into 10 equal parts. So 7 times 15 will be 105 divided by 10. So 105 divided by 10 will be 10.5. So in our first rule, if the quotient obtained is not a whole number, since the answer is not a whole number, 10.5, so if the quotient obtained is not a whole number, round it to the next larger whole number. So since the next larger number of 10 is 11, so we will going so the answer will be the 11th decile. So our 11th decile will be 52. So the value of 7th decile will be 52. The last or the third common measures of relative position will be percentiles of ungrouped data, the score points which divided a distribution into 100 equal parts. Since our quartiles is into 4 equal parts and our deciles is into 10 equal parts, our percentiles from the word itself percent, so percent means 100% or is equivalent to 100%. So percentiles will be into 100 equal parts. So just like the formula of the deciles, there are some similarities between the formula of percentiles and deciles. So instead of D, we're going to use P. Pk equals Kn divided by 100. We will not use 10 because in percentiles, there are into 100 equal parts. So we're going to use 100. So just like the rules in deciles, to get the location of percentile, if the quotient obtained is not a whole number, round to the next larger whole number. And the second rule is if the quotient is a whole number, use the value halfway between the kn over 10 th plus kn over 10 plus 1 raised to the power of th. So the fifth example or the first example of percentiles of ungrouped data so that you will going to understand it more. The list shows the number of bottles of blueberry jam sold in a day by 12 different vendors. 19, 16, 10, 12, 15, 13, 9, 11, 17, 18, 15, 20. So for 33rd percentile. So we're going to arrange the scores in ascending order. Since there are 12 different vendors, our N will be 12. So 9, 10, 11, 12, 13, 15, 15, 16, 17, 18, 19, 20. This will be the scores in ascending order. So pk equals kn over 100 is the formula to get the percentile. Since so our k will be 43 since we're going to find the 43rd decile and our n will be 12 since they are 12 scores over 100 since it is percentile. We're going to find the percentile. 43 times 12 will be 516 divided by 100. So our PK or our 43rd percentile will be 5.16, since in the rules that if the quotient obtained is not a whole number, round the next larger whole number. So since the next larger number of 5 is 6, so 6 percentile. So our 6 percentile will be 15. So our 43rd percentile will be 15. So to sum it up, our 43rd percentile will be 15 since it is the list of numbers of bottles of blueberry jam sold in a day by 12 different vendors. So our 43rd percentile will be 15. Thank you for listening and hope you learned something. Thank you and God bless.